Everyone, welcome to this new video of our series Virtualization with Hyper-V. In this video, we are going to talk about various virtual machine components that a Hyper-V virtual machine is built of so that we can understand the responsibilities and functionalities of all these components. So let's get started and take a look at the list of all those components which comprises a Hyper-V virtual machine. So in this list, you can see we have got virtual firmware, BIOS, UEFI, virtual memory, virtual processor, virtual hard disk, virtual storage controllers, virtual switches and network adapters, and virtual machine files. So let me tell you, in case of a physical computer, we have got a central processing unit, CPU, we have got the memory, we have got hard drives. So a physical computer is built of all these components. The same way, a virtual machine also has all these components. It's just that it will have all of these in the emulated form, or we can say that it will have all of these in the virtual form. So that's why the firmware, memory, processor, hard disk, all these are called virtual in case of a virtual machine. So we are going to take a look at each and every component to understand what is the functionality of each component and how it works in case of a virtual machine or in a virtual environment. Let's talk about the virtual firmware component of Hyper-V virtual machine. We all are aware that firmware is a chip which is integrated on the motherboard of a computer, and it is an integral part of the boot process when we start the computer. Let's discuss what is this boot process, and we all need to understand the boot process before we work on any computers or virtual machines so that we can understand what process it goes through in the background when we start the computer. So as soon as we press the power button, there is a code which is written on this firmware chip. It gets initialized and then it starts the post process. Now this post process is power on self test. It checks all the connected hardwares of that computer, that every hardware component is connected properly and is in healthy state. If it finds that there is some problem with any component, it could be with the hard drive or it could be with the RAM or any hardware component. If it finds any problem, then it shows you the message on the screen and your computer does not start in that case. Your computer will only start when the post process verifies and confirms that every component is connected properly. Once it verifies, then it sends the control to MBR. Now MBR is one of the disk partition styles. Whenever we initialize a disk, we have to define the partition style, whether it will be MBR or GPT. So disk can support MBR and GPT both. Depending on MBR and GPT, the properties of that disk varies. So there are some benefits of GPT and MBR, which we will discuss in our later on slides. Now this MBR contains your operating system. This is the first sector of your disk, which is called your boot sector. This boot sector holds your operating system. So once the control is sent to this MBR, then it initializes the operating system code and your computer starts booting up, and then you see the Windows screen on the computer. Once the operating system initializes and the code gets executed, then you get the user login screen, and then you can log in with your credentials and your computer boot process will be completed. The same process is followed in case of virtual machines as well. So there are two kinds of firmwares. One is BIOS and UEFI. BIOS is known as the legacy firmware, which supports MBR, and UEFI is the upgraded version of BIOS, which provides better performance, and it supports MBR and GPT both. In the similar way, in virtual machines, we have got generation 1 virtual machines and generation 2 virtual machines. In Gen 1 virtual machine, it supports BIOS and it supports 32-bit as well as 64-bit guest operating systems. In Gen 2 virtual machines, it supports UEFI firmware and it only supports 64-bit guest operating systems. So when we will start creating virtual machines, we'll have to define that whether it will be a Gen 1 virtual machine or it will be a Gen 2 virtual machine. And depending on that, its firmware will be defined. Next, we are going to talk about virtual memory in Hyper-V virtual machines. So just like we have physical RAM in case of physical computers, we have got virtual memory in virtual machines. We divide virtual memory in two parts, dynamic RAM and fixed RAM. In dynamic RAM, we can define minimum and maximum RAM limits. So in this picture, as you can see, we have defined 512 MB as minimum RAM for this virtual machine and 12 GB as the maximum RAM. So what does this mean? This means that when this virtual machine will start, it will only occupy the minimum amount of RAM that we have defined to it, and it can extend itself to the maximum amount of RAM as per the application requirements that will run on this virtual machine. So it's not like that this virtual machine will lock up the whole 12 GB. It will only lock the amount of RAM which it requires. So the rest amount can be used by the physical hardware for the virtual machines. So that's why it is called dynamic RAM. And second one is fixed RAM. In case of fixed RAM, the virtual machine locks up the amount of RAM that we assign to it. So let's suppose we have assigned 8 GB of RAM to a virtual machine, which is the fixed RAM. So in that case, that 8 GB will be locked by this virtual machine, whether any application is running or not on this virtual machine. All that 8 GB will be used by this VM only. The physical hardware cannot assign that 8 GB to any other virtual machine in that case. Next component in Hyper-V virtual machine is virtual processor. We all know that CPU is a very critical part of a computer. It is the heart of a computer that performs all the operations, all input and output related operations of a computer. Now, in the same way, we have got virtual processors available for virtual machines. Now, these virtual processors depend on how many physical cores we have on our physical hardware. The more physical cores we'll have on our physical hardware, the more virtual processors be available for our virtual machines. And then as many number of virtual machines we can create with that. How the equation work of these physical CPUs and virtual CPUs, we are going to understand that now. So one core of physical CPU is equal to 8 virtual processors. So if we have got a physical hardware which has got 2 cores in it, that means we can assign 16 virtual processors to our virtual machines in that Hyper-V host. And depending on that, we can create multiple virtual machines. If we assign 4 virtual CPUs to a virtual machines, and 4 is the maximum number of virtual CPUs that you can assign to a Hyper-V virtual machines. So always remember, 4 is the maximum number of virtual CPUs that you can assign to a Hyper-V virtual machine. So based on that, if we have got 16 virtual CPUs available and we are going to assign 4 virtual CPUs to each virtual machine, then we can create 4 virtual machines with that. Next scenario, if we are going to assign 2 virtual CPUs to each of our virtual machines, then we can create 8 VMs with 2 virtual processors in them. And if you are going to assign 1 virtual CPU to each of our virtual machines, we can create 16 virtual machines with 2 physical cores of our physical hardware. So that's how this equation works. So whenever you assign virtual processors to your virtual machine, make sure that you have got enough physical cores available in your physical hardware. And the more physical core you will have, the more virtual processors you can assign to your virtual machine, and the better will be the performance. Next component in Hyper-V virtual machine is virtual hard disk. So the storage of any virtual machine is represented in the form of virtual hard disk. So there are two kind of files which are available in Hyper-V, VHD and VHDX, that represents the virtual hard disk of any virtual machine. VHD was supported by Windows Server 2008, 8R2, 12 and 12R2 Hyper-V hosts, where Microsoft introduced VHDX since Windows Server 2012. So any virtual machine that will create in Windows Server 2012, 12R2, 16, 19 and 2022, that will give us the option to create the virtual machine in the form of VHDX only. It will not allow us to create the VHD format of virtual hard disk. And there are many benefits that VHDX has over VHD that we are going to discuss now. So VHD only supported the fixed storage type. So we used to assign some amount of storage to the virtual machine, and that could not be changed dynamically. Where VHDX provides us the functionality to assign fixed as well as dynamic storage to any virtual machine. So dynamic means that it will not lock up the whole storage from the physical hardware. It will only use as per its requirement, and the rest of the storage can still be used by physical hardware for other virtual machines. And then whenever this particular virtual machine will require more storage, it can be presented by the physical hardware because it has the available. Next difference is the VHD format could only support 2 terabyte size of disks, where VHDX supports the disk up to 64 terabyte. And there was no data protection available in VHD types of virtual hard disks, where VHDX provides the data protection from data corruption. And VHD has the logical sector size of 512 bytes, where VHDX has logical sector size of 4 KB. So whenever we used to store data in VHD, it used to be divided in multiple chunks so that it could be filled up in that logical sector, because the sector size was very small. Where in VHDX, the sector size has been increased to 4 KB, so the data can be stored in an efficient way. Live resizing was not possible for VHD files, so whenever the virtual machine was running, we could not resize that virtual machine in case of VHD. Where in VHDX, we can resize that virtual machine even if the virtual machine is in running state. And VHD does not store metadata, where VHDX stores metadata, which helps us in protection against the data corruption during power failures by logging updates to the VHDX metadata structure. Next component is virtual storage interface. There are two kinds of virtual storage interfaces available in Hyper-V hosts and virtual machines: ID controller and SCSI controller. The main responsibility of these controllers are to act as an interface between your virtual machine and your virtual hard disks. So any operation between your virtual hard disk and virtual machine will be driven by these controllers. And one controller can support multiple virtual hard disks. You can connect multiple virtual hard disks with one controller. All the Generation 1 virtual machines supported ID controller as well as SCSI controllers, where Gen 2 virtual machines only support SCSI controller. SCSI controller provides better performance than compared to the ID controllers. ID can be called as a legacy controller, so that's why SCSI is an upgraded one, and all the Gen 2 virtual machines only support SCSI controllers. So next is virtual switch and virtual adapters. We can create virtual switches and virtual adapters in our Hyper-V environment. We all are aware about the physical switches, right? Physical switches are used for all the computers to be able to communicate with each other in a LAN network. In the same way, we can use virtual switches so that our virtual machines can communicate with each other, as well as they can communicate with Hyper-V host and external networks. So for that, we need to create virtual switches. There are three kinds of virtual switches that we can create in Hyper-V environment: private, internal, and external. So first, if we talk about private virtual switches, these private switches allows the virtual machines to be able to communicate with each other, but they cannot communicate with the Hyper-V host. So there is a limitation in private switch that VMs can only communicate within each other. So that's why this private switch is generally used for isolated networks whenever we need any testing or lab purpose network. For those kind of reasons, we can use private switches. Next is internal switch. In case of internal switch, all our virtual machines can communicate with each other, as well as they can communicate with Hyper-V host, which was not possible in private switch. So with internal switch, all of our VMs can communicate with each other and with Hyper-V host, but they cannot communicate to the external networks. Third one is external switch. In case of external switch, all of our virtual machines can communicate with each other, as well as with the Hyper-V host and with the external networks as well. So as external switch can access the external networks too, so that's why the virtual machines can access internet when we use external switch. So whenever we create internal and external switch, a virtual adapter gets created on our physical host. So we can assign IP address on it and define the network range that this particular virtual switch or virtual adapter will be used for. All of our virtual machines will get a virtual network interface card whenever we create a virtual machine, and we can create as many, or we can add as many virtual NICs to a virtual machine that we want, and we can connect it to different networks as well. Next is virtual machine files. When we create a virtual machine in Hyper-V, there are some certain files that gets created along with the virtual machine, and basically a virtual machine is a combination of these files. Till Windows Server 2012, these files were XML, bin, VHD, and AVHD. And Microsoft has introduced some new file types since Windows Server 2016 and for the later versions of Windows servers. These new files are VMCX, VMRS, VHDX, and AVHDX. So let's first talk about the prior version of files in Hyper-V virtual machines. So till Windows Server 2012, a virtual machine used to have XML, bin, VHD, and AVHD files. XML is the configuration file for any Hyper-V virtual machine, which stores the information about the virtual machine configuration. Bin file is used to contain the memory of virtual machine in saved state. Now what is a saved state? So let's suppose we have a virtual machine running and we have some applications open in it, Notepad, Edge, Google Chrome, etc. Now we want to turn it off, but what we want is that when we turn it back on, all these applications should be running automatically. So for that purpose, we put the virtual machine in saved state. And we need to save that memory somewhere. So that's why bin file is used to save that memory for virtual machine saved state. Next is VHD. VHD is the storage file for any virtual machine till Windows Server 2012. And then we have AVHD. AVHD is the snapshot file for any virtual machine. Whenever we create a snapshot of a virtual machine, AVHD file will be created. Now let's talk about the new file types. Microsoft has introduced new file types since Windows Server 2016 and to the later versions. These new file types are VMCX, VMRS, VHDX, and AVHDX. VMCX is the configuration file for a virtual machine in Windows Server 2016 and later versions, and it comes in the binary format. Earlier, it used to be in the XML format, but Microsoft has now changed its format to the binary so that we have a better readability. Then we have VMRS. VMRS is the runtime state information file which stores the runtime information for a virtual machine. Then we have got VHDX. VHDX is the storage file for a virtual machine in Windows Server 2016 and later versions. Earlier it used to be VHD, but VHDX has got more benefits over VHD in case of storage capacity and data read and write operations. It has got more benefits. Then we have got AVHDX. AVHDX is the snapshot file for a virtual machine. Earlier it used to be AVHD. Now in Windows Server 2016 and later versions, it is called AVHDX file. Alright, that's it for today. I hope you got an understanding of all these virtual machine components which are very important to create an Hyper-V virtual machine. In our next videos, we will learn how we create a virtual machine, how we set up networking and storage of virtual machines. So it was very important to understand these virtual machine components before we start creating the virtual machines. Now we will be able to easily understand that how a virtual machine is created in Hyper-V and how we perform other operations with Hyper-V. So let's meet in our next video. Till then, thank you everyone. Bye bye. Take care.